하시코프 코리아 박세준입니다. 이제 완연한 봄이 됐는데 아직도 코로나 때문에 직접 모시고 진행하는 행사를 하기에는 무리가 있어서 부득이하게 이렇게 온라인 행사를 진행하게 되었는데요. 그래도 여러분이 많은 관심을 가져주셔서 등록도 많이 해주시고 또 응원도 많이 해주셔서 많은 IT 리더분들하고 함께 리더십 세미나를 오늘 진행할 수 있게 돼서 진심으로 감사한 마음입니다. 간단하게 오늘 세미나 순서를 말씀을 드리면요. 저는 오늘 저희 최석인 이사하고 함께 행사의 진행과 질의응답을 도울 예정이고요. 그리고 오늘 행사의 주된 세션은 저희 APJ 세일즈 VP이신 데이빗 칼레스의 인사만 하고, 그리고 저희 본사 CEO이신 데이브 맥자넷의 클라우드 오퍼레이팅 모델에 대한 소개와 발표, 그리고 저희 고객이신 아모레퍼시픽의 테라폼 엔터프라이즈의 도입 성공 사례 발표로 이런 방식의 순서로 진행을 할 예정입니다. 세션에 앞서서 간단하게 공지드릴 부분은 이번 행사는 동시통역 서비스가 진행되고 있기 때문에 현재 보고 계시는 화면 아랫단에 있는 언어를 선택할 수 있는 통역 버튼이 있거든요. 거기에 그 통역 버튼을 통해서 자유롭게 원하는 언어로 선택해서 발표를 들으시면 되고요. 그리고 세션이 모두 끝난 이후에는 역시 화면에 보이시는 Q&A 버튼을 통해서 자유롭게 질문해 주시면 저희가 발표자분들에게 전달을 해서 질의에 대한 응답이 원활하게 이루어질 수 있도록 할 테니까 아낌없이 질문도 부탁드리겠습니다. 그럼 이제 첫 번째 순서부터 한번 진행해 보도록 하겠습니다. 앞서 소개해드렸던 저희 APJ 세일즈 VP인 데이빗 카레스입니다. Over to you, Dave.
Thank you, Luke. And good morning, everybody. As Luke mentioned, my name is David Carlos. I'm the Vice President of Asia Pacific and Japan for HashiCorp. And I've been with the company about 3.5 years. So I've seen a lot of change throughout the region. And we're super excited today to be sharing some of the things that we're seeing, not just across Asia Pacific, Japan, but also across the rest of the world via our CEO, Dave McJannet. Thank you again for joining. Today, we're going to help you to understand how HashiCorp is helping organizations across the world to digitally transform their business by facilitating the use of cloud infrastructure and modern application delivery. As our CEO, Dave, will explain, HashiCorp enables the provisioning, securing, connecting, and running of applications and the infrastructure to support them. At HashiCorp, we're investing heavily in Asia Pacific, Japan, and particularly in South Korea. You've met Luke. We have an office in Seoul now, and we're also hiring more both sales and technical staff to help us serve the South Korean market. You'll also see that organizations are facing challenges as they move to the cloud. One of our customers, AmorePacific, a well-known brand name in South Korea in the region, will explain some of the challenges that they faced and how we've helped them to overcome. But our customers are from all industries. They include banking customers in the region, such as Standard Chartered Bank, Commonwealth Bank of Australia, Shinhan Bank, SoftBank, DBS, retail, including Amore, Coupang, Rakuten, Woolworths, Vingroup in Vietnam, manufacturers such as Samsung, Honda, and SAIC General Motors in China, and of course, telecommunications such as Telstra, SK Telecom, LGU Plus, and Singtel. So we really hope that you enjoy this morning's webinar. Thank you so much again for joining. And obviously, we look forward to your feedback at the end of the seminar. We'll have an opportunity to ask some questions. But for now, I'd like to hand over to our CEO, Mr. Dave McJannet.
Thank you, David. Let me turn my video on. First of all, let me welcome you this morning and thank you for joining us today. I have met a good number of you previously on my visits to the region, but obviously it's been some time since that has happened. So this digital medium is the best we can do until we can meet in person again. as David highlighted, if we can just go to the next slide, the way we think about the world is around how do we enable the way to interface to cloud. We have a whole series of products. In fact, today we have 8 products. You see them on the right-hand side. They are all distinct and do different things, but they are all in the common category of how do we enable people to adopt the cloud model for infrastructure. And I'll talk more about that as we go through this. I'll make the point that all of these products that you see here are made available as open source. So Vagrant was the very first project introduced in about 2012. Waypoint is our most recent project. We make them all available in open source. And so what we almost always find is that every organization that we engage with is already using these products somewhere. And I would suggest that your organizations are probably no different. It may not be obvious at the most senior level where you are, but at the practitioner and user level, by and large, I've never come across a company that doesn't use our products somewhere in their infrastructure stack. The most popular product people think about us for is probably Terraform, but actually our most widely used product up until recently is in fact Consul, and I'll share as to why. As I said, this grouping of products all have a common idea, which is how do we enable people to standardize how they interface to cloud infrastructure in support of their company initiatives for building and running applications on Amazon, Azure, Google, or wherever it might be. So if we can go to the next slide. Our company, as David highlighted, he joined us about 3.5 years ago. We've actually been around for almost 10 years. Today we count 12, actually it's probably closer to 1,300 people. To give a sense, we're trying to hire almost 1,000 people this year, just because the market is moving so fast, and our customer base is growing equally fast. And so we continue to invest very, very deeply in the company, but just know that we are not a small company in the technology sense. And you know, for those that may have interfaced with us 3-4 years ago, just hopefully it is clear that we have become a much larger company over the course of time. And I can show you on the next slide. This is a little bit what it looks like today. If you think about our product adoption, we probably get about 100 million downloads of our products every year. It's a truly incredible number, and that's how they make their way into your organization in open source form. On our hosted managed offerings, because we do have a managed version of Terraform, a managed version of Vault, a managed version of Consul, we probably have 100,000 companies on those products already. And then in terms of our true people running directly self-managed software, we have about 1,400 customers. And that is because the biggest companies in the world would rather self-manage their infrastructure as opposed to consuming a managed service from us. So while we have both options, our largest customers, like those of you on the phone, on the call today, generally want to run this software themselves. We have about 1,400 of those. And it tends to skew towards the very, very high end. We count 145, almost 150 of the Fortune 500 as commercial customers. 500 of them are open source users, but 145 are commercial customers. And a little under 300 of the Global 2000 are commercial customers. So as you can see, our products are not just being used by users at a really, really large rate. They, over the last few years, have really become cemented as the foundational way that people interface to cloud for almost 150 of the Fortune 500. And that number is obviously growing very, very quickly. If we go to the next slide. The way we think about the world is that we are going through an infrastructure transition that only happens once every 30 years. If you rewind, 30 plus years ago, all of your applications were running on mainframes. And then the next transition was to running infrastructure on your traditional data center on x86 systems. In fact, my very first trip to Korea was in 2002 to go spend time at Hyundai HMC, and they were having issues with their HP Superdome back in that previous era of computing. So that world, while complicated, I have servers, I have networks, I have IP addresses, is quite well understood. It's complex, but it is the world we know because all of our new applications for the last 30 years have been being delivered onto this commodity x86 world of hardware. And that's largely supporting the key business applications that you have today. Next slide. If you look at what's happening now, is actually this transition now is from this dedicated world where you largely run your own infrastructure, that now actually all your new applications, by and large, are getting deployed onto Amazon or Azure or Google. And while you still have a huge number of applications running in your private data center, the connectivity to the cloud is becoming a much more significant element of how you run infrastructure. Your ability to do that in a consistent way is becoming a constraint to your growth because the applications you are building must run on cloud. The database may be running on a data center, but the applications are running on cloud because the cloud model is just really well suited to the kinds of applications we all build today. For example, an application like Zoom that we're using right now, that is designed to run on cloud infrastructure. Why? Because it spins up and spins down as it comes under load, and it just is really, really well suited to that model. And so we can all appreciate that all of the new applications of the world, by and large, are going to be deployed onto this cloud model for the next, n number of years, being quite a large number. The challenge is that the operating model for how to run infrastructure in this world is actually really different than the operating model for the world that we are all living in today and coming from. Right? On the old model, I have servers, IP addresses, firewalls, complicated, as I said, but well understood. In the new world, how do I think about the core principles of how to run that infrastructure where there is no firewall, there is no static IP address? How do I think about sort of stepping back and understanding how to interface to this new world? Next slide. The good news is that this model is actually really well understood. The model of how to run infrastructure that you talk about is the cloud operating model, has been developed by the cloud native companies like many of you, like Coupang, like these other companies that are cloud native, like Slack, like Zoom, like Stripe, and all the companies we all use every day, like Samsung Mobile, and all these companies that have understood how to do this. And that is now being adopted at scale inside most enterprises because it is well understood. It's no different than you went from mainframe, how do I run mainframes? How do I secure mainframes? How do I connect them together? To having to learn how to do that in the current world. Hey, how do I run my own data centers? How do I connect everything together? Okay, we learned how to do that. And now we're all learning how to run cloud infrastructure, which is just different. We decompose the problem into four categories, and whether you use our products or somebody else's products, what we've learned as we've gone around the world over the last 10 years is there are four parts to the problem that everybody has to identify, and they align to the four personas or the four types of roles in IT. So the ops people at the bottom are tasked with the how do I provision infrastructure problem. In the old world, in the current world, I probably use a tool like VRA or vRealize Automation from VMware or something like that. And when I have to spin up more compute capacity, somebody opens a ticket, I then open up the VRA tool, I provision a virtual machine, I close the ticket, and then I email them back and say, there's your machine, or now you have more compute capacity. It's just not really well suited for the velocity of the modern applications. And so the new model for the ops team is they have to learn how to provision compute capacity in the cloud world. And what the world has learned is you can use infrastructure as code to give an instruction set to a platform. You don't open up a tool and press a UI. You give it an instruction set in the form of an infrastructure as code or a codified template and say, Amazon, spin me up 100 machines that look like this. Amazon, spin down 100 machines that look like this. Azure, spin up 100 machines or spin down 100 machines. So the transition that your ops teams are going through is having to learn how to do that in the new model, because that is what's being required of them. So great, understood. I have to understand infrastructure as code as the new model. At the security layer, there's an equivalent philosophical difference. What we are all used to, and our security teams are used to, is to say, let's use the network perimeter as the basis of protection, where everything inside the data center, good, everything outside of the data center, bad, right? And I can create a firewall around my world and mitigate the risk. In the cloud world, your problem is you don't own the network. So there is no real construct of a network that you control, because it's designed to expand and contract as your compute farm comes and goes. So it requires just a philosophically different model for doing security. And that security model has a different core idea. And that core idea, rather than being about IP address as the basis of security, it's around the basis of identity as the basis of security. A really well understood concept in the world of people to machines. We all do it every day when we log into our networks. But what about machine to machine? If most of my applications are comprised of machines talking to machines, how can I use identity as the basis for deciding whether these things can talk to each other or not? So that is a very different concept for security people, and very different from the old world, because frankly, the idea of a firewall doesn't really make much sense in a world that is cloud, because things are moving around all the time. So got it, okay, understood. That's what my security team has to get their heads around, which is thinking about security through the lens of identity. For the networking teams, their problem historically is based on, hey, this physical machine has a physical location, therefore I create a networking rule that says this machine talks to this machine on this IP address, right? And because they are static, they are not moving around, that works really, really well. When I deploy more infrastructure, someone then updates the networking rules for those things to talk to each other. The problem in cloud is, again, things are designed to move around, and they're designed to come and go. Again, I spin up 100 machines in the morning, spin down 100 machines at night. So it's impossible for a human to update the networking rules fast enough for that to happen. And as a result, the long pole for your application seeing traffic is the ability of your networking teams to update the rules for networking. Obviously, that is not an acceptable model, which is for any application of any modern type. So instead, philosophically, the networking world reorients around the idea of service networking, which is say this thing can talk to this thing, and when it talks to it, just allow it to connect. So it's service to service networking as opposed to IP networking. Obviously, a machine is keeping track of the actual IP address where these services are, but the logical routing is service to service. The way that Zoom and Slack and Stripe and all the modern applications of today do networking is that way. They don't do it using traditional Cisco networking gear. They do it based on the service to service notion. Again, making my point that this model is actually super well understood. It's not that it's not complicated. Sure, it has complexity to it, but it's also really well understood and really well proven, because Amazon and others have been doing this for a better part of 15 years. For your developers at the very top of the stack, who's ultimately we serve, there is a variety of application platform types. Some of the applications might be containers, some of them might be virtual machines, some of them might be serverless elements, some of them might be running on edge. There's just a variety of application types on top. But the concept is different, again, from the old world. I used to give my developers an IP address and say, drop your artifact onto that app server. Now I give my developers the ability to drop their artifact onto my fleet, and I schedule it across that fleet using a modern scheduler. So those are the 4 core principles, which are really, really different in the cloud model. And I think this is probably the most important thing to understand, is just that those 4 things are different in the cloud model. There are 4 of them, but they're also really well understood and really well proven. And if you go next slide, you will see this is in fact exactly how the cloud providers make available their infrastructure. So if I were to use Amazon, look for that column, the way I tell Amazon to spin up more compute is not through opening a user interface and clicking, pointing and clicking. Yes, you can do that, but that's not an operable way to do that consistently. I use a tool called CloudFormation, which gives an instruction set to Amazon to spin up compute. If I, when I think about the security layer, everything that spins up on Amazon is assigned an identity. That identity is the basis of all security. So can this thing talk to this thing? I don't know. What's its identity? It's moving around. What's its identity? So every security, the core security control is based on the identity group that this element belongs to. So identity just is the core element of security in the cloud model. At the networking layer, yes, you can use software-based networking that looks exactly like, Palo Alto Networks on-prem. There's a software version of Palo Alto Networks or Cisco that you can drop in. And so you can do that. But what the cloud native companies do is they actually use Amazon's cloud native service networking product, which is called Cloud Map, which allows you just to declare this element talks to this element. It's that notion of service-based networking, which is how scale companies just have to do things on cloud. And then on top of that, they just let you run any type of application platform, whether it's Kubernetes service, the container service, Lambda, whatever it might be. There's just a whole range of technologies on top. And so you sort of go, okay, great, that makes sense to me. I'm using Amazon. This is the core construct of all of Amazon. And then you realize, wait a second, I also have to run some applications on Azure. And you say, all right, let's look at how Azure thinks about these principles. And it turns out Azure has the identical principles, but they are implemented differently because each cloud provider is its own walled garden. It only really cares about itself for obvious reasons. And so your issue is, if you are an enterprise of any size, is you have to now understand Azure Resource Manager, which is kind of like CloudFormation, but it's the Azure version. And if you use Google for anything, you have to learn Google Cloud Deployment Manager, which is kind of like CloudFormation, but different. And if you want to apply that same concept to your on-prem fleet using vSphere, well, I can use Terraform for that. So you end up with this different variety of technology choices, which each make perfect sense, including identity on Amazon, identity on Google. They all make perfect sense in their own world, but are practically impossible to work with if you are trying to standardize in any way how you deliver applications to cloud. So the question then becomes, for every organization, if my task is about how do I interface to more than one cloud provider in particular, what elements does it make sense to externalize and actually externalize outside of the cloud providers in terms of the native services that the cloud providers provide, so that I can have some modicum of standardization so that I can allow a consistent way to deliver applications to cloud while still meeting the needs of ops security and networking, which are ultimately going to be the blocker for any application seeing traffic. Next slide. So what we do, what our mission in life is just about providing consistency. It's about standardizing the core elements of these markets entirely in open source for the good of everybody, because it's good for everybody if the world standardizes on Terraform as the basis of infrastructure provisioning. I would guess most people on this call use Terraform for infrastructure provisioning. Why? Because it's the standard. It actually reduces the learning curve for everybody of how to interface to Amazon or Azure or Google. And as a result, that's actually really good for Amazon and Azure and Google, because it makes it easier for people to consume their services. And it's actually really good for the end user market for all of you, because you have now a standard way to interface to them. So it's good for the cloud providers, and it's good for the end user. And as a result, we've seen enormous standardization. I'm not sure what percentage of Amazon's revenue on any given day is provisioned by Terraform, but it's an enormous number. They know that, we know that, and that's actually good for everybody. So Terraform plays that standardization role, and as a result, the cloud providers invest deeply in Terraform because it's good for them. The same thing happens at the security layer, where you may have an application on Amazon that needs to talk to a database running inside of a virtual machine. If you want to use identity as the basis for how to do that, I need a common way to broker identity across this application and this application, whether that use case is for managing credentials or whether it's for encryption, whatever it might be. You have to have that common mechanism for brokering identity, and Vault is that. I think we've shared that 14 of the 20 largest financial institutions in the United States run Vault in production. Gives you a sense for how common it is. So Vault plays that role at the security layer. And what most people do is they will run a standard shared service of Vault as the way to interface to cloud. Console provides a common registry that lets you see where everything is. And then now I have a map as to where all my services are on Amazon or on Azure or wherever it might be. And now I can start driving networking automation based on knowing where everything is in the world. And then at the top layer, Nomad is our offering for scheduling. Unlike Kubernetes, it's just a scheduler. It's not trying to be an application platform. It's just a scheduler. And I'm going to skip Nomad for the purposes of this conversation because I want to really focus on Terraform, Vault, and Console. But we're happy to talk about Nomad, which has enormous usage around the world, but it's sort of a very specific conversation. So what the question then becomes is, what elements should I be externalizing of my infrastructure approach as I go cloud? And if you go next slide, you'll see for most people, this is what it looks like. For 150 of the Fortune 500, give or take, what they do is they say, great, I'm going to have to work with Amazon, Azure, Google, and on-prem. Those are my four infrastructure targets that I have to work with, whether I like it or not. How do I basically pull out which elements I'm going to standardize on so that my organization as a whole can deploy applications wherever they choose? What people tend to do is they'll create a cloud program office, generally speaking, which is part of the infrastructure organization. And they will stand up a central shared service of Terraform and say, hey, the only way you can provision compute on Amazon or Azure or vSphere is by going through our central shared service. And that's when they use our commercial offering. The security team says, great, the only way an application can go to Amazon, Azure, or Google is if you use Vault as the basis of security. So they run a central shared service of Vault. And then the networking team says, I also want you to run a central shared service of Console so we know where everything is. So when things get deployed, we can update the networking rules dynamically to accommodate for the fact that things got deployed. And at the runtime layer, this is more of a maturity question. There tends to be slightly less standardization, but our biggest customers standardize on Nomad as the common interface for scheduling across any of those fleets. So the takeaway here is you're building all kinds of applications and they're using the cloud native services from Amazon, Azure, or Google for databases and message queuing and all the things that you need for your application. You need to standardize on the common elements for ops security and networking. And by and large, that's Terraform, Vault, and Console for most organizations around the world to enable that to happen. The cloud native companies of the world, by and large, this is what it looks like, whether it's Slack or Stripe or Zoom or, pick your cloud native company, or Roblox or, pick your company. This is what it's looks like. They are built on HashiCorp products. They just are. And that blueprint is now being adopted by everybody else, which I think is a really comforting thing for everybody because, the technology approach that's really well proven by the biggest applications on the planet is now being adopted by the biggest companies on the planet as they start to progress towards cloud. And if there's one learning, certainly for us as a vendor, is this market is extraordinarily early. So yes, we have some companies, and I know Samsung and others have been quite public about how committed they are to cloud, but many companies are actually really early in this transition. And so the good news is those that are early are getting to learn from those that have already done this. And this is generally what the blueprint looks like. So let me just spend a minute talking about each of the individual products. Next slide. Let me talk about Terraform. So that's the principle. That's what success looks like. Let's talk a little bit about the details. So Terraform, its goal in life is to allow you to use infrastructure as code to create a reusable template that gets given to a cloud platform to stand up infrastructure. So I want in a single template to be able to describe all the Amazon elements I want to be configured, plus all the dependencies, Datadog, Kubernetes, Snowflake, whatever it might be. Every time somebody wants to spin up infrastructure, I just want this blueprint stood up. I don't want any variation from it. I just want that blueprint because that's what's approved. By doing that, we've largely standardized the market on Terraform as a language through our rich provider ecosystem, which means, not only are there providers for Amazon, Azure, Google, Alibaba, and the core cloud platforms, there are actually another 400 providers for all kinds of different technologies you want to interface with to allow that to happen. And then our commercial version of Terraform really allows you to apply cloud compliance and management, right? So if I run a central shared service of Terraform, what I can now do is have a singular way that everybody goes to cloud. So now I have audit trails. I can enforce that nobody can provision anything other than the topology and the template that I've set out. And then I can also see who's done it, who has access to it, what are the audit trails. I can create rules that says nobody can provision after 5 p.m. on a Friday, or nobody outside of this resource group can create new templates. So that notion of multi-cloud compliance is a key driver of why people standardize on Terraform, because it gives you control of what's going to get spun up. People describe this as shift left for security. I prevent security outages in my cloud platform by not allowing anybody to stand up anything that's not already approved, right? The second use case under that tends to be around this idea of self-service. So if I want to allow, I may have 100 development teams. I don't want to get in their way and have them open tickets for me to spin up infrastructure. I want them to be able to just consume this template. And so I just create a rule that says, as long as you're consuming this template, as part of your CI/CD process, you can provision infrastructure 100 times a day, 1,000 times a day. I'll get out of your way because I've created a self-service model for you as the development team to provision infrastructure when you need it, while giving me the comfort to know as an ops person that you cannot do anything that I've not pre-declared. So these are kind of the two core use cases of Terraform. Next slide. Vault, again, totally different product. And I know many of you on this call use Vault already. The core idea of Vault is, how do I authenticate your identity before I give you access to a backend system? So, I'm an application, I want to talk to a database. In the old world, I would have just let you talk to each other because you're running inside your private data center. In the cloud world, we need a secondary step, which is, let me first get you to assert your identity before I let you talk to that backend system. And that's the role that Vault plays. So, if you take this picture on the top, I have a client on the top who wants to talk to the backend system on the right. I want to first have you authenticate your identity using the identity model that is appropriate to you. If it's a container running on Amazon, I want you to authenticate yourself using the Amazon identity. If it's a database running, or if it's an application running on prem, I want to use Active Directory or LDAP or Okta or OAuth or whatever the identity model that matters to you is. So that that concept then can get applied to any number of use cases. The most common use case is for secrets management. So how do I, instead of storing my static credentials for that database inside the application, how can I have Vault be the broker of credentials so that the application itself does not actually have the credentials to that backend system? Because then if I get breached, I have a problem, I'll end up on the news. How do I use Vault as a way to broker that credential management process? And it's generally described as secrets management. It could be application secrets, it could be infrastructure secrets, it could be anything. But the idea is, how do I manage secrets? And Vault is used by most companies for that. There are other use cases, though, that are really, really popular using that same idea. One of those is around data encryption, and one of those is around the advanced data protection use cases, things like tokenization of data for your developers so that they can send a bunch of data to Vault and have it returned tokenized, basically without any easily identifiable information in it, for the purposes of application development. So this core idea of Vault as an identity broker becomes an incredibly powerful thing. And so it's why people almost always externalize this out of their clouds and run it. They may run it inside one of the clouds, but they don't rely on a cloud native service for this function, because they want to be able to have a consistent workflow across apps running on Amazon or apps running on-prem. Next slide. Consul, as I mentioned, is actually our most widely used product, or it was until recently. It was, in fact, the first product that we built because we needed it ourselves before we could drive automation more generally across the fleet that we were running. The simple idea of Consul is, I want to first and foremost create a common service registry that tells me where everything is. I may have some services on-prem and some services on Azure, acknowledging that on Azure, the service registry tool is unique. And on Amazon, they have a different service registry tool. On-prem, you have a different service registry tool. Step one, let me understand where everything is. So let me create a common service registry. I run an instance of Consul. Every time something net new is deployed, it updates Consul server and says, oh, I'm a container running on port 1.1.1.1. Now Consul knows where you are. That is then used as the basis for automation. So first and foremost, let me have a singular view as to where everything is and what its health is. Or is this application healthy? I don't know. This service is down, that service is down. Got it. So as a way to inform your monitoring tools, monitoring approach, that's super, super common. But the bigger use case is, how do I drive actually networking automation? By the fact that I now know where everything is, how can I start driving dynamic networking decisions? So when I deploy more instances of this, the load is then balanced naturally across the additional instances that I've got. Well, Consul is used as the basis for network automation, and we're happy to talk more about that. But that's kind of the core use case. Number one is around service discovery. Number two is, now I know where everything is. Now let me use that as the basis of driving networking decisions. And you can do that either dynamically for entirely in software, or we also have the capacity in partnership with Cisco, Juniper, F5, Palo Alto, and all the big networking vendors to apply that to legacy hardware as well. And I'll talk about that in a minute. And then the third use case for Consul, and perhaps this is the one where most of the noise comes from in the market, is around the idea of service mesh. And a service mesh is actually nothing more than, once I'm driving service-based networking decisions, just encrypt the traffic between the services. So the idea of using mutual TLS to encrypt every connection everywhere is a foundational principle of the zero trust security model. And that's one of the massive drivers of Consul, is the fact that I can enforce encryption between every application without modifying the applications themselves, simply by having a proxy server run at the basically inside localhost on every machine, and allow them to tunnel between services when they connect. So that service mesh notion is why Consul is inarguably the world's most widely used service mesh in production. Next slide. So I've talked about the product specifically, and so perhaps I can just talk about sort of a common pattern of adoption. And I think we talk about this idea of a cloud operating model, but the use cases, broadly speaking, underneath that, actually, yes, there's product-specific use cases, but really they fit in three categories. The first is around the idea of like infrastructure provisioning and infrastructure automation. The second is the idea of zero trust security. And the third is the idea of this sort of DevOps process of delivering applications quickly to cloud infrastructure, like the cloud native companies do. I worked at GitHub for a while. I'm guessing many of you use GitHub. We used to deploy GitHub 12, 13 times a day. Wow, we would deploy updates to GitHub 12 or 13 times per day. How do you do that? How do you deal with the infrastructure side of that? Well, again, I'll tell you the answer is simple. The shortcut is Terraform, Vault, and Console is how that's done at GitHub, like everywhere else. But that's the idea, is how do I have this DevOpsy process of application delivery? And I think you'll find the answer is very, very consistent. Next slide. So let's talk about the most common journey of adoption. Let's just solve one problem at a time and show how the combination of the products is sort of designed to solve these core like use case problems. The first one is, how do I automate the infrastructure provisioning process in a way that unlocks velocity, allows my ops team to get out of the way? So step one is around using Terraform as the basis of infrastructure as code. I would almost guarantee that 90% of you on this call today already do that with Terraform. All right. Step two, next slide, is what you find is now actually I have a group of people inside of your organization that are all using Terraform as the basis for how they spin up compute. How do I stop them from stepping on each other? How do I stop them from both trying to provision at the same time? Well, now you have a collaboration problem. Next slide. And now you're trying to work around the idea of collaborative infrastructure as code. And that's where most of our commercial customers begin. It's like, hold on a second. It's like going from Git to GitHub, really. It's like, I have a bunch of people that are using Terraform. Hold on a second. I got to bring this under control. Let's standardize, create a central shared service of Terraform, and that therefore have a prescriptive workflow or prescriptive way that people work together, a common audit trail, a way to apply policy in a singular way so we can collaborate safely around the infrastructure provisioning process. Next slide. Then there's sort of the next logical evolution is it's great. Now I've got everybody collaborating around infrastructure as code, but I, as the security team, for example, I want to enforce policy. I want to be able to say, nobody gets to deploy anything onto Amazon that is not encrypted, for example, or nobody can provision after 5 p.m. on a Friday, as I said earlier. And so this idea of policy as code, if you go next slide, is sort of the second use case that I talked about previously, is about, great, I've started using Terraform commercially. Now I want access to the policy as code libraries so I can start codifying the rules for this stuff. And that's the second use case. And then ultimately, this comes down to the idea on next slide of how do I use this approach, I'll go next slide, to automate the configuration, not just of my cloud infrastructure, but for my legacy hardware as well. We see a lot of people use Terraform for the configuration of networking gear. And in fact, you may have seen an announcement we made 2 weeks ago where Cisco has agreed to resell Terraform Cloud, our commercial product. And I think that speaks to this reality, which is Terraform is starting to be used not just for the cloud side, but also increasingly for the configuration of networking gear as well. And that's why we have the facility with Terraform plus Console to allow this much more dynamic motion. If Console is being used as the basis of service discovery, then when new infrastructure gets deployed, right, Console knows that new infrastructure has been deployed. Now, how do I use that to inform the infrastructure provisioning for my networking gear to acknowledge the new infrastructure that just got deployed? And how do I do this in a more dynamic way? So the infrastructure provisioning problem starts with just using infrastructure as code, becomes collaboration around the infrastructure as code, and ultimately gets to this much more sophisticated use case of dynamic networking configuration using Console with Terraform. So, that if that's of interest to you, I would love to talk more about that, and I know Luke would as well. To me, this is actually one of the most interesting things that we do, is this combination of Console plus Terraform to allow you to automate networking rules in a much more dynamic way. Interestingly, while I'm talking about this in the cloud context, what we've seen over time is some of the very largest organizations in the world started out using this model for their cloud fleet and actually now standardize on this for their entire on-prem fleet as well, because there are Terraform providers for vSphere and everything else. So let me go next slide. So let's talk a little bit about the security journey. As I mentioned, people externalize not just Terraform, but also Vault. They start with Vault for this core use case of identity, basically machine authorization and authentication for the purposes of secrets management, right? Secrets management is the most common starting point. Why? Because all of the public breaches in cloud have come from situations where somebody was able to get into the network, they were able to find a database, they were able to find the credentials for that database, and then they dumped that database on the internet. So the most common place where security teams start in cloud is, I'm not going to let that happen. You must use an external credentials management model, i.e. Vault, as the basis of credentials management for that fleet. And that is why Vault gets brought in for secrets management. Next slide. For the zero trust solution to be solved, though, you also need to encrypt traffic between all the machines that are connecting to each other. So it's not enough really for me to authenticate the identity of this machine before I give it access to that machine. What I really want ultimately is another layer of defense to say, like, when this machine actually connects to the other machine, for step one, authenticate its identity using a certificate. Step two, encrypt the traffic between those two machines, and that way I'm extra safe. That's a very well understood model in the cloud world, not contentious, really well understood. And that is one of the core use cases of Consul. So if you use Vault and Consul, as most people do, you start to be able to get deeper and deeper into the zero trust model for all of your machine-to-machine connectivity, and also encrypting all the relationships between those machines. Next slide. You also notice that the third element of the zero trust approach has to deal with people-to-machine access. So there's no silver bullet for zero trust. There's just a series of defense in depth motions. The first two I talked about. The third one is that every time a person wants to connect to a machine or an entity running in cloud, I want you to authenticate its identity and do it in a cloud native way that doesn't require me to log into some intermediary host and then navigate east and west from inside of there, as the older models of privileged access management do. And that's our Boundary product. Now, Boundary is an earlier product. We announced it in October of last year, and it'll be in beta this year. And its goal in life is to fill that other piece of the puzzle around zero trust, which is the people to machine problem. So Vault and Consul for machine to machine, Boundary for people to machine. So that's our approach to zero trust. Happy to talk more about that. You'll see, again, that's just a native cloud concept that's not complicated. It's super well understood. Now it's just being brought into the mainstream market. Next slide. Lastly, I'll talk about the application delivery process, and you'll find, again, the core ingredients are the same: Terraform, Vault, and Consul. This is how everybody from GitHub to Slack to everybody in between uses for their application delivery process. Because in the traditional world, it is a very waterfall-oriented model where I spend time doing development, then I open a ticket for someone to spin up infrastructure, then I have the security team bless that environment, I have the networking team update the routing rules, and then lastly, I deploy the application onto that runtime environment, and off we go. That takes many weeks. Next slide. The cloud native companies do that in 5 minutes. Why? Because they've externalized the core constructs of infrastructure security and networking in a way that I can now just, regardless of where this application is going, I can use a consistent model. And it is that idea of a consistent application delivery process that really unlocks the velocity that you're trying to solve for. So those are the three core scenarios: one around infrastructure automation, one around zero trust, and one around the application delivery process and shrinking that. The answer, and again, this is not a vendor specific view, this is just a playing back what we've learned from the market over the last 5 to 7 years, is Terraform, Vault, and Consul as externalized things run by a central shared service team are how most people in the world do this. And that's not exaggeration as much as just reflection on what we discover when we travel around the world. Certainly some parts of the world are more advanced than others, but I find it amazing that I would argue many of the people on this phone call already use Terraform, Vault, and Consul as the basis of their cloud programs, even if they're just running on Amazon. And I'd love to know if that's true from the audience. Next slide. I'll close by just giving a couple of examples just to share how real this is. One of the things that shocks me most is when I travel around the world, and most countries that I go to, people say, yeah, the stock exchange here also settles through HashiCorp products. and sometimes they talk publicly about it. So this is the Toronto Stock Exchange. The Toronto Stock Exchange processes, I don't know how many billions of dollars a day of transactions, and have an enormous amount of infrastructure to enable them to do that. They talk publicly about how Terraform is the basis for how they, and Terraform commercially is the basis for how they do this. And actually how they talk also about how Vault is the basis for authenticating every transaction as well. Next slide. Athena Health is one of the big health providers in the United States. Just to give an example and hopefully give you some comfort that this is being done at enormous scale. You are not the first people to do it. In fact, the opposite is true. This is very, very well adopted and advanced. Athena Health, for their health record access process, they process more than 300 million requests for secrets every single day through their shared Vault infrastructure, right? It's how the applications exchange credentials with the backend system. It's in the runtime path of every request, every single request, 300 times a day. And actually both massively reduces the security exposure and risk associated with application access, but it also allowed them to hugely reduce operational costs by automating the process, which in many instances was manual previously. Next slide. The last one I'll just talk about because it's kind of fun. And Roblox has been very public about how they are built entirely on the HashiCorp stack. They talk about how they use Nomad, but in the same case study, they also talk about how they use Terraform, Vault, Consul, and Nomad altogether as the basis of how Roblox works. And I think it just speaks to my earlier point. This model is well understood and already running at enormous scale by the cloud native companies, and so is, over the last 5 years has made its way into the enterprise. So I'll end there. Next slide, and just say, that the cloud model is really well understood. And it's now being adopted by the Global 2000. We would love to, be a partner as you think about how to approach this. We have a team in Korea, obviously, and 1,000+ people around the world. But I think more than anything, we have the unique luxury of seeing the patterns of how people are accomplishing this in every major enterprise around the planet. And I think we can be a true partner, which is our goal, just to help participate in the journey that you are no doubt on. So I will end there and hand things over to Luke, but we'll stay on for questions at the end. Thank you.
네, 클라우드 운영 모델에 대한 좋은 발표 감사드립니다. 다음 순서는 저희가 저희 테라폼 엔터프라이즈 고객이신 아모레퍼시픽의 정재열님으로부터 디지털 혁신을 주도하는 아모레퍼시픽의 인프라 현대화라는 제목으로 테라폼 엔터프라이즈 도입 성공 사례에 대한 발표를 들으려고 합니다. 오늘 발표해 주시는 정재열님은 네오이즈, 스마일게이트 등의 그 선도적인 기술을 도입 진행했던 IT 기업에서 시스템 엔지니어 그리고 클라우드 플랫폼 엔지니어로 15년 동안 종사하셨고요. 그리고 현재는 아모레퍼시픽의 디지털 오퍼레이션 플래닝 팀에서 인프라 총괄 업무를 담당하고 계십니다. 이제 한번 들어볼까요? 그러면 정재열님께 마이크를 넘기도록 하겠습니다. 정재열님 부탁드릴게요.
네, 반갑습니다. 네, 소리 잘 들리는지 모르겠네요.
네, 잘 들립니다.
네, 반갑습니다. 오늘 이렇게 국내 이렇게 처음으로 세미나인데 저희를 이렇게 초대해 주셔서 감사드리고요. 저희가 작년부터 해서 테라폼 엔터프라이즈를 저희 구매했고 준비했던 사례를 다들 기술적인 보다는 어떻게 대략적으로 어떻게 준비했냐를 해서 간단하게 좀 설명드리는 사례를 갖도록 하겠습니다. 예. 먼저 아까 설명드렸지만 저는 한 15년 동안 일단 IT 업계에서 뭐 시스템 엔지니어부터 해서 클라우드 업무 담당했고, 현재 아모레퍼시픽에서 인프라 업무를 총괄하고 있습니다. 예. 예. 간단하게 저희 회사를 뭐 다들 아시겠지만 간단하게 소개해드리면, 뭐 저희가 뭐 저희 회사 주장은 아시안 뷰티 대표 회사로서 모두 일반적으로 알고 계시는 설화수, 헤라, 아이오페 등 화장품 브랜드와 오솔로, 해피바스 같은 생활용품 등 약 60여 개의 브랜드를 보유하고 있고요. 현재 아시아뿐만 아니라 전 세계적으로 약 10개의 글로벌 지사를 운영 중이며, 미국과 유럽 그리고 이제 뭐 중국 같은 지사에서 각종 저희가 화장품 브랜드로서 아시아만 대표하는 게 아닌 글로벌로 대표하는 기업으로 성장하고 있습니다. 예. 예. 그리고 저희가 저희도 뭐 알다시피 이제 아모레퍼시픽도 저희가 현재 최근에 있는 저희가 디지털 트랜스포머 전략에 맞춰서 오프라인 중심에서 디지털 중심으로 업무를 지금 계속해서 준비를 하고 있고요. 또 다시 변화를 하고 있는 과정입니다. 네, 그래서 뭐 최근에 뭐 아시피 저희가 AP몰에서 보면 저희가 뷰티테크 같은 신기술 도입하고 디지털 지향적인 업무를 진행하고 있고, 뭐 혁신 제품으로서는 저희가 뭐 최근 친환경 상품 등 많은 제품들을 수로 출시하고 있습니다. 네, 그래서 안 들리나요? 네, 죄송합니다. 잠시만. 네, 죄송합니다. 저희 회사에 간단하게 뭐 IT 전략이나 이런 걸 간단히 소개해드리겠습니다. 이제 뭐 많은 분들이 여기 계신 많은 분들이 아마 최근에 많은 이런 IT 변화에서 이런 용어를 많이 들었으라고 생각하고 있습니다. 뭐 가장 큰 트렌드로서는 아니면 디지털 트랜스포메이션을 통해서 트랜스포메이션을 위해서 많은 기업들이 현재 많은 인력 리소스와 비용을 투자하고 있는 거라고 지금 믿어 의심치 않고 있고요. 이에 관련돼서 AI나 머신러닝 같은 뭐 기술들을 기반해서 많이 준비를 하고 있을 거라 생각하고, 이런 기술들에 대한 문화를 준비하기 위해서는 아무래도 클라우드 서비스를 많이 활용하고 있을 거고, 이 클라우드를 잘 사용하기 위해선 클라우드 네이티브라는 말이 아마 필수적으로 알고 계실 거예요. 그러니까 그래서 클라우드 네이티브 잘 수행하기 위해서는 뭐 CI/CD나 마이크로 서비스 아키텍처, 데브옵스 컨테이너에 대한 많은 용어를 들었을 거고, 이런 거를 준비하기 위해서 저희 뭐 오토메이션 같은 툴에서는 현재 오늘 얘기하고자 하는 IAC, CI/CD 그리고 가장 기본이 되는 모니터링 같은 이런 많은 용어들을 접하고 있을 거라고 생각하고 있습니다. 저희 또한 이 기술을 말은 기술이 아니고 실현을 하기 위해서 많은 리소스와 비용을 투자하고 있을 거라 생각하는데요. 저희 또한 똑같이 진행을 하고 있고요. 저희 아모레퍼시픽에서는 기본적으로 IT 전략으로 해서 보시다시피 뭐 많은 큰 부분이 있겠지만 일부분 발췌한 내용인데요. 제가 담당하고 있는 운영 플랫폼 부분과 뭐 다른 이제 모니터 부분이 있는데, 오늘 얘기하고자 하는 부분은 이제 운영 플랫폼 부분에서 소스 관리나 뭐 CI/CD, 그다음에 ARM 같은 어플리케이션 라이프 사이클 매니지, 그다음에 프로비저닝, 오케스트레이팅 같은 이런 툴이 많은 영역을 제가 담당하고 있는데, 이 부분에 대해서 많이 좀 고민을 많이 했었고, 어떻게 구현을 하면 빨리 할 수 있고, 저희가 또 이거 저희가 디지털 트랜스포머에서 디지털로 가기 위해서 어떻게 저희가 인프라에 도움이 될 수 있을까 많이 고민을 하고 있었습니다. 예. 그래서 제가 와서 좀 많은 고민을 했었고, 그런 고민 중에 저희가 테라폼이라는 제가 툴을 뭐 과거에도 알고 있었지만 현재 이 툴을 좀 활용해서 어떻게 하면 이걸 커버했을까라고 생각을 했었고요. 근데 그 부분에서 지금 색깔을 칠해진 부분 마이그레이션, 현재 작품 마이그레이션과 현재 CI/CD 그리고 각종 뭐 테스트, 성능 테스트나 테스트 같은 부분, 그리고 프로비닝 같은 오케스트레이션이나 자동화에 관련돼서 이 테라폼이 많은 역할을 했었고요. 물론 앞 뒤에 다시 설명을 드리겠지만 테라폼을 통해서 여기에 있는 이 영역에 대해서 커버가 되었고, 이 커버된 부분을 통해서 현재 저희가 지금 보시면 커스터머 CDP 같은 커스터머 데이터 플랫폼이나 현재 AP몰, 아리따모, 인스몰 같은 이커머스몰, 그리고 그 외에 이제 추천, 이제 리뷰 같은 이제 AI 머신러닝 같은 서비스를 저희가 구축을 지원하고 있고, 또한 뭐 계속해서 현재는 뭐 완벽하진 않겠지만 이것저것 계속 확장하고 있는 상태입니다. 예. 뭐 다들 아시다시피 일반적인 그 대기업 엔터프라이즈 기업에서는 아마 기본적으로 IT 전략을 따실 때 아마 멀티 클라우드 전략을 많이 생각하고 계실 거라고 생각합니다. 그래서 저희 자사 같은 경우도 아직까지 뭐 전체 다는 아니지만 궁극적으로는 뭐 멀티 클라우드 전략을 당연히 필요로 하고 있는 거고, 현재로서는 저희가 온프라미스와 AWS 환경을 주로 하고 있고, 현재 하이브리드로 서비스하고 있지만 이 뭐 궁극적으로 차후에는 뭐 애저나 구글, 그러면 중국 같은 경우는 알리온 서비스를 해서 준비를 하고 있습니다. 예. 그래서 이 부분에 대해서 테라폼이 큰 역할을 하고 있는 것 같습니다. 제가 보기에는 테라폼이 지금 현재 있는 모든 멀티 환경, 멀티 클라우드 환경에서 프로비저닝 같은 아까 앞단에 보였던 그런 영역에서 많은 도움이 되는 거로 제가 알고 있고, 저도 실제 겪고 있는 상황입니다. 예. 좀 짧게 말씀드리면 저희가 테라폼을 구축하고 난 다음에 앞서 이런 부분을 구현을 하기 위해서 진행을 했지만, 실제 제가 이제 저희 회사에 약간 구축되는 걸 보여드리는데, 일반적으로 아마 테라폼이라면 프로비저닝, 그러니까 ISC, 인프라 프로비저닝에 대해서만 생각하고 있을 거라고 생각하고 있는데, 자세히 제가 인프라 대기업에 와서 이제 엔터프라이즈 기업에 와서 제가 실제 운영을 하고 겪은 상황은 어떻게 되냐면, 많은 업계들이 지금 보면 CI/CD 같은 많이 꼭 필요한 상황이죠. 프로비저닝하고 CI/CD 하는데, 클라우드 서비스를 하면서 CI/CD 연동하는데 대부분의 업계 저희가 대기업들을 보시면 다 SI 위주로 해서 실제 이 업무를 진행하고, 물론 뭐 내부에 현재 인력 개발 업무 개발자들을 충원해서 개발팀을 만들어서 하는 게 있겠지만, 아직까지 대부분의 업체들은 SI 업계들과 같이 업무를 진행하고 있는데, 이런 SI 업계들은 아직까지 클라우드에 대한 뭐 경험이나 그런 개발 플랫폼들이 아직 많이 좀 미비한 상태입니다. 그러다 보니까 저희가 클라우드 서비스 사용하고 있지만 실제 CI/CD 연동을 하기 위해서는 많은 어려움이 있었는데요. 특히 이제 저희가 AWS 서비스 사용하면서 코드 시리즈 이제 코드 디플로이를 통해서 디플로이 하기 위해 작업을 하는데, 많은 개발자분들이 이제 하시는 얘기가 어떻게 개발하냐, 뭐 어떻게 지금 연동하냐, 이거 도와주면 안 되냐, 이런 얘기가 엄청나게 많이 좀 들어오는 상태라서 제가 이것을 테라폼을 준비하면서 그냥 단순하게 프로비저닝만 하지 말고 CI/CD도 같이 연계해보자, 그러니까 개발자들 좀 편하게 제공해보자라는 생각에서 제가 저희 쪽에서 많은 커스터마이징, 그러니까 그 테라폼에 있는 그 샘플 코드 모듈을 가지고 와서 저희 쪽에 자사에 맞게끔 CI/CD, 그러니까 배포를 하면, 그러니까 프로비저닝 하면서 CI/CD까지 같이 연계를 할 수 있게끔, 쉽게 연결할 수 있게끔 환경을 만들어 보자 라서 작년부터 해서 진행을 했었고요. 그래서 현재로서는 지금 저희는 AWS의 기반이기 때문에 테라폼에서 프로비저닝을 하면 코드 시리즈 통한 파이프라인 구성과, 그리고 주로 사용하는 서비스 EC2, 람다, 컨테이너 통한 ECS, EKS 같은 서비스를 프로비저닝뿐만 아니고 CI/CD까지 한 번에 배포할 수 있게끔 구축을 해놓은 상태입니다. 그래서 이걸 하기 위해서는 당연히 뭐 앞에 있는 템플릿화 작업도 진행해야 되고, 저희가 많은 주로 사용하는 모듈에 대해서는 당연히 커스터마이징 작업을 했고, 그리고 이에 따라서 저희가 내부에 있는 인력을 통해 내부에 있는 기술자 엔지니어를 많지는 않지만 저 포함해서 그래서 많은 노하우와 자산을 가지게 되었고요. 지금은 현재는 일반적인 뭐 이아스 서비스 위주로 했지만, 저희가 앞에 보여드렸지만 AI나 머신러닝 같은 서비스는 대부분이 아마 클라우드 서비스 하게 되면 사스나 파시언트 서비스 많이 사용하고 있을 거라고 생각합니다. 그래서 그런 서비스를 차후로 계속해서 준비 중에 있고요. 그리고 궁극적으로 말씀드리고 싶은 거는, 현재 저희가 앞단에 있는 건 서비스 단위로 이렇게 준비를 하고 있지만, 실제 아마 모든 분들이 원하시는 건 아마 제가 많이 듣던 얘기가, 프로비저닝 이런 IC 툴 쓰면 아무 때나 뭐 만들어진다며, 그러면 어떻게 해야 돼? 결국은 예를 들어서 제가 현재 서비스 테라폼 쓴다고 하면 지금의 구성들은 대부분 아마 뭐 한 개의 왓 서버, 한 개의 API, 웹 서버 이런 식으로 구성할 건데, 저희가 추구하고자 하는 것은 이런 모듈들 합해서 예를 들어서 멤버십 서비스를 구축한다. 그러면 하나의 멤버 서비스에는 뭐 왓서버, 웹서버, 배치 서버, DB 서버, DB 이렇게 많은 서비스가 있을 겁니다. 그러니까 그런 서비스를 한 번에 구축해서 어느 환경이든 손쉽게 짧은 시간에 구축하게 하고 앞서 플랫폼 중에 보였던 테스트, 그러니까 성능 테스트 같은 경우에는 상시적으로 캐노피가 없기 때문에 이렇게 IAC나 아니면 테라폼 모드를 통해서 서비스에 대한 모든 그 구축이 되면 필요할 때 모두 해당 서비스를 만들고 테스트를 끝나면 내리고 이렇게 하면 클라우드에 대한 어떻게 보면 효율적인 사용이 돼서 아마 많은 분이 고민하고 있는 클라우드 사용하면 비용이 싸진다는데 싸지지 않고 있죠. 근데 그거가 결국은 뭐냐면 이렇게 효율적으로 사용한 자동화나 이런 효율적인 툴을 사용하지 않기 때문에 생기는 현상이라고 보는데 이런 앞서 제가 구축했던 이런 템플릿화 이제 서비스처럼 이렇게 모든 게 서비스가 구축이 되면 IC가 구축이 되면 아마 그런 비용적인 부분과 시간적인 리소스 부분에 많이 효과를 얻지 않을까라고 생각하고 있습니다. 그리고 저 또한 그걸 기대하고 계속해서 지금 테라폼과 함께 지속적으로 그 구축을 진행하고 있습니다. 뭐 저희도 알다시피 기본적으로는 제가 저희 회사에서 얻고자 하는 거는 지금 글이 안 보이는데 보자 하는 거는 결국은 셀프 서비스 인프라인 거죠. 그러니까 무슨 얘기냐면 개발자분들이 결국은 누구의 인프라 도움에서 이렇게 통해서 하는 게 아니라 인프라에서는 뒤에 백단에서 이런 자동화된 솔루션, 삼성 같은 뭐 SR 같은 게 제가 알고 있기로 뭐 SR이라는 용어를 통해서 아마 그렇게 플랫폼을 구축해주고 있고 저희 흔히 아는 데브옵스 이런 문화를 하기 위해서는 개발자분들한테는 제가 하고자 하는 거는 꼴을 얻고자 하는 거는 개발 인터페이스를 제공해주면 그 인터페이스를 활용하면 저희가 구축한 인프라 환경에서 IAC를 통해서 IAC나 이런 CI/CD 자동화 툴을 통해서 개발에서 필요한 모듈 저희가 표준화된 인터페이스를 맞춰서 작업하면 개발을 완료한 동시에 자동으로 배포, CI/CD부터 해서 서비스 운영까지 자동으로 할 수 있게끔 그리고 추가적으로 모니터링까지 모두 할 수 있는 환경을 만드는 게 궁극적으로 저희가 골로 가지고 있고요. 그 골을 가기 위해서 저희가 뭐 예전부터 뭐 기본적인 CI/CD 이제 뭐 개선하기 위해서 많은 단계를 거쳐왔고요. 일반적으로 근데 저희가 현재 단계는 저희가 IC 자동화를 통해서 인프라 자동화를 단계가 있고 그 다음 단계는 저희가 머신러닝 이런 인프라도 앞선에 있는 일반적인 AI 머신러닝이 아니라 인프라 자체도 머신러닝 같은 돌려서 저희가 또 서비스 미리 선제 작업을 할 수 있게끔 이런 환경 구축을 하고 궁극적으로는 개발자분들한테는 이렇게 손쉬운 환경을 제공하고 회사 차원에서는 개발과 운영이 이렇게 빨리 선순환될 수 있는 구조를 만드는 게 저희를 꼴로 가지고 있습니다. 근데 저희가 앞서 많은 서비스를 구축을 제가 했지만 저도 IT 출신이다 보니까 기본적으로는 이런 솔루션 도입보다는 일반적인 오픈소스를 활용해서 많은 서비스를 구축해 왔고요. 했지만 제가
근데 잠시 또 라이브의 묘미인 것 같네요. 예, 좀 그 인터넷 연결 관련된 부분에 렉이 걸린 것 같은데 지금까지 들으셨던 세션의 내용들 가지고 자유롭게 채팅해 주시면 됩니다. 채팅하셔서 알려주시면 되고 다시 준비되셨을까요? 네네, 말씀하시죠. 음성이 나오지 않네요. 지금 뮤트가 걸려 있습니다. 네네, 말씀.
죄송합니다.
네, 이제 다시 들립니다.
네, 네트워크 상태가 안 좋아서. 지금 잘 들리시나요?
네, 자료도 띄워주셔야 될 것 같아요.
자료 안 보시나요?
네.
잠시만요. 이거
네, 전체 화면으로 해주시면 되겠습니다.
네.
네.
죄송. 어디까지 다시 한번 설명드리겠습니다. 제가 이제 그 앞에 많은 이제 커스터마이즈 작업과 템플릿화 작업을 진행하면서 실제 이제 저희가 운영 단계에 가다 보니 제가 결국은 저희가 IT 여기서 총괄하던 업무를 진행하다 보니까 이런 서비스를 저희가 뭐 IT에서 제가 이 작업을 했지만 실제 이거는 사람의 의존적인 시스템인 거죠. 무슨 얘기냐면 저희가 엔터프라이즈, 그러니까 일반적인 IT 기업에서는 엔지니어나 개발자분들이 되게 많아서 이런 걸 요란하게 운영이 될 수 있겠지만 저희가 이런 엔터프라이즈 기업은 대부분 관리자 인력이 더 많을 거고 실제 운영을 하기 위한 엔지니어 수급도 쉽지 않은 걸로 알고 있습니다. 뭐 최근에 알다시피 뭐 이런 인력 수급을 위해서 대표해서 뭐 넥슨 같은 사태가 발생했고 많은 개발자 인원 미리 공급받기 위해서 그런 일도 있었던 걸로 기억하는데 이렇게 그러니까 사람의 의존적인 시스템을 하다 보면 저희가 결국은 이런 엔터프라이즈에서는 결국 나중에는 인력 공급에 대한 뭐 부족한 현상이 당연히 있을 거라고 생각하고 약간 리스크를 가지고 있고요. 이렇다 보니까 결국은 서비스에 대한 가장 중요한 엔터프라이즈 가장 중요한 서비스 지속성, 이 연속성을 기대하기 힘들 거라고 약간 판단이 되었고요. 이렇게 지속성을 당연히 힘들면 아까 앞서 말했던 인력 공급도 제대로 하게 되면 전체적으로 궁극적인 서비스 품질 유지가 품질 유지가 어려운 상황이 됐다고 제가 리스크 고민을 하게 되었습니다. 이런 고민을 좀 해결하기 위해서 제가 국내에 있는 이제 하시코프사에 연락을 해서 테라폼에 관련된 이제 기술 지원을 같이 얘기를 했었고요. 같이 논의한 결과 이제 제가 엔터프라이즈 거를 검토하게 되었습니다. 엔터프라이즈 솔루션을 검토하게 되었고 앞서 얘기했던 이제 많은 이제 오픈소스에도 충분하게 뭐 서비스를 활용할 수 있겠지만 궁극적으로 이런 엔터프라이즈 기업에서 운영을 위한 어떻게 시스템에 필요한 사항을 하기 위해서 엔터프라이즈 기업을 검토를 통해서 도입하게 되었고요. 이런 도입을 통해서 첫 번째로 알다시피 이제 사람의 의존적인 시스템보다는 시스템의 의존적인, 그러니까 시스템을 통한 플랫폼 운영을 가능하게끔 제가 된 것 같다고 생각하고 있고요. 결국은 시스템 운영을 하고 난 다음에 이런 솔루션 엔터프라이즈 계획을 하면서 뭐 하시코프에 있는 뭐 테라폼 엔지니어뿐만 아니라 현재 국내에 있는 다른 벤더사를 통해서 안정적인 인력 공급을 할 수 있을 거라고 제가 기대를 하고 있습니다. 물론 아직까지 국내에는 많은 이제 파트너사 아직 부족한 걸로 알고 있는데 이 부분 좀 많이 하시고 빨리 좀 충원을 해주시면 좋겠고요. 그리고 이런 걸 통해서 저희가 안정적인 기술 지원과 운영에 대한 걸 기대할 수 있을까 생각했었고 검토한 과정에 당연히 저희가 엔터프라이즈 기업에서 운영하기 위해서는 기본적인 운영, 앞서 뭐 설명은 했지만 폴리시나 이런 보안 정책을 통해서 기본적인 인프라에 대한 거버넌스 적용이 돼야지만 차후에 운영이나 이런 ITSM 같은 우리 관리를 체계를 갖출 수 있을 거라고 생각하고 있었고요. 엔터프라이즈에서는 당연히 그 기능을 적용하고 있었고요. 했어서 많이 좀 빨리 적용할 수 있을 거라 기대를 하고 있습니다. 그리고 추가적으로 뭐 워크플로우 같은 업무를 통해서 저희가 오픈소스를 통해서는 자연적으로 이제 그런 워크플로우 같은 경우도 뭐 당연히 구현을 할 수 있겠지만 엔지니어나 이렇게 되게 힘들게 좀 구현하는 상황이었습니다. 근데 이제 워크플로우 좀 더 쉽게 구현을 할 수 있었고요. 그리고 뭐 저희가 알다시피 앞에 있는 많은 플랫폼들이 있을 겁니다. 그러니까 아까 뭐 운영 플랫폼 포함해서 뭐 앞에 SI 요청 이런 많은 이제 요청 모니터링 같은 많은 서드 파트 솔루션이 붙을 건데 테라폼 엔터프라이즈 도입하면서 얘는 기본적으로 이제 API와 이제 이번에 인터페이스를 많이 제공하기 때문에 이런 서드 파트 솔루션과의 연동이 좀 더 쉽게 연동을 할 수 있고 현재 준비하고 있는 제가 지금 앞에 보여드리는 건 테라폼만 얘기했지만 저희가 다른 분야에서 지금 모니터링 포함해서 뭐 SI 요청, 뭐 지라 이런 것들에 대한 거를 같이 진행하고 있는데 여기에서 한 번에 지금 연동을 좀 더 쉽게 할 수 있어서 현재 많은 도움이 될 거라고 지금 현재 저희 구축하는데 속도를 좀 높일 수 있을 거라고 생각하고 있습니다. 예. 예, 짧게 제가 이렇게 저희가 엔터프라이즈 테라폼을 도입하고 테라폼 엔터프라이즈를 도입하게 된 것을 설명을 드렸는데요. 물론 제가 이 자리에서 뭐 좀 더 개인적으로는 뭐 기술적으로 어떻게 좀 더 설명하고 싶고 막 이렇게 좀 세게 설명하고 싶지만 그 부분은 혹시 다음에 또 기회 되면 제가 한번 더 준비를 하겠습니다. 제가 뭐 이거 앞에 다들 알다시피 제가 마지막으로 하고 싶은 말은 이제 저희가 현재 코비드-19 때문에 그러니까 뭐 코로나 사태 때문에 현재 많은 변화를 있는 거고 뭐 오프라인 중심에서 온라인 중심으로 좀 사업이 많이 변화가 되고 있고 뭐 비대면 서비스들이 당연히 주류로 이제 바뀌고 있는 거죠. 뭐 일부 기업들은 쿠팡과 뭐 배달민족 같은 일본 기업들 당연히 급성장하고 있고 변화를 못하는 뭐 역성장을 뭐 맞는 기업들도 당연히 있을 거고요. 근데 저희 같은 경우도 이제 미리 이렇게 이런 디지털 중심, 그러니까 오프라인 중심에서 디지털 중심 미리 받고 있고 이 부분에서 큰 역할 중에서 오늘 얘기하고 있는 뭐 애자일한 인프라를 당연히 필수적으로 제공해야 될 거라 생각하고 이렇게 사업 디지털 중심 바뀌다 보면 당연히 속도가 지금 중요하다고 생각하고 있습니다. 속도에 적시적소로 저희가 IT 지원하기 위해서는 애자일한 인프라를 지원해야 되고 이 인프라 지원하기에 중심에 있는 게 아마 이 IC 같은 툴, 테라폼은 오늘 설명해준 테라폼 툴이라고 생각하고 있고요. 현재 뭐 저희가 65개 뭐 템플릿 포함해서 65개 모듈 뭐 커스텀 많은 작업을 했지만 앞으로도 많은 일이 남아 있을 거라 생각하고 있습니다. 그래서 많은 도움을 아직도 테라폼과 많은 도움을 협조를 진행하고 있고요. 현재 구축된 이 IC 플랫폼이 저희 쪽에 있는 AmorePacific 포함해서 많은 사업에 큰 힘이 될 거 믿어주시지 않고요. 이렇게 짧은 시간 동안 경청해 주셔서 감사하고 제가 다시 한 번 더 기회 되면 다음에는 좀 더 디테일하고 좀 더 성과 위주로 해서 많이 좀 공유할 수 있는 자리가 있었으면 좋겠습니다. 네, 감사합니다.
네, 발표 감사합니다. 저는 하시코프 최석인입니다. 지금부터는 저희가 이제 Q&A 세션을 진행해 보려고 하는데요. 우선은 궁금하신 부분이 있으시면 채팅창에 한글로 남겨주시면은 저희가 저희 CEO 뭐 데이비드 맥자넷이나 또는 아모레퍼시픽에서 답변을 주실 수 있도록 저희가 말씀을 드리겠습니다. 저희가 첫 번째 질문이 있으신데요. 우선은 제가 한번 보도록 하겠습니다. We have a question like, what is the priority and the most important things we need to prepare for, like to adapt the business technology and new technology for the cloud journey? And because most of the current customers have a silo organization, such as different dev teams, operation teams, and security teams. So we need to get some sponsorship from the C-levels, but we don't have actually no core organization to handle or has ownership for these kind of issues. So this question is actually for you and the AmorePacific both. So if
I'll let the AmorePacific answer first.
Yes. So 재열님도 지금 이 질문에 혹시 아모레퍼시픽 같은 경우 이런 조직이 별도로 존재하는지 말씀해 주시면 좋을 것 같고요. 아니면 어떻게 조직 세팅을 하셨는지도 알려주시면 좋을 것 같고, 제가 데이비드 맥자넷에게는 해외 사례도 한번 말씀을 드려보겠습니다. 재열님 지금 뮤트가 되어 있습니다. 뮤트를 풀으시고 혹시 이런 클라우드 오퍼레이션 조직 어떻게 핸들링 하셨는지 한번.
네네. 사실 뭐 이런 조직적인 문제는 저보다도 더 상위 레벨에서 많이 얘기를 하시는 게 맞을 것 같은데, 뭐 저는 얘기했지만 한 2년 전에 이게 아모레퍼시픽에 처음 왔게 됐고요. 그때 제가 알기로 저희는 디지털 관련 조직에 새로 아마 구축을 새로 이제 조직을 이제 세팅했었고, 내부에 있는 개발팀부터 해서 일반적인 내재화를 위해서 많은 인력을 충원을 했었습니다. 그래서 기본적인 구조, SI에 있는 인력 플러스 현재 내재화돼서 이런 신기술을 도입하기, 신기술과 디지털 트랜스폼, 그러니까 CDP나 이런 디지털 트랜스폼에 기여하기 위한 멤버를 많이 이렇게 제가 구직해서 조직을 구성한 걸로 알고 있고요. 현재 알다시피 사람만 뽑았대서 되는 건 아니고요. 이거 아까 스폰서십에서 저희도 이제 많은 CIO님 포함해서 CTO님, CDO님 포함해서 저희가 많은 이제 이런 스폰서십을 받고 있습니다. 받고 있고, 그에 따라서 뭐 최근에는 지금 뭐 제가 알겠지만 저희가 애플리케이션 모듈라이제이션을 통해서 CFT 조직도 저희가 구축 예정이고요. 뭐 올해 아마 이번 달에 아마 구축이 될 건데, 이런 식으로 구축해서 전사적으로 하기에 앞서 이제 내부에 있는 특정 개발 조직, 이제 내부에 있는 인프라 조직을 통해서 어떤 모델을 먼저 만들고요. 그 모델을 통해서 점점 확장하는 구조를 저희가 준비를 하고 있습니다. 예. 그래서 제가 세부적인 조직적인 문제라서 제가 말씀을 좀 드리긴 좀 애매하고요. 일단 기본적으로 저도 뭐 2년 전에 왔지만 이런 인프라 쪽 IT 인력이 뭐 확보는 쉽지는 않겠지만 뭐 통해서 뭐 와서 일부적인 내부 조직을 위한 세팅은 필요할 거라 생각합니다. 그러니까 단순하게 기존에 있는 멤버들도 당연히 성장을 위해서 기존에 있는 전략이나 인프라 담당하는 멤버를 그렇게 할 수도 있겠지만 밖에서 일차적으로 IT에 경험이 있는 멤버들과 와서 하시면 좀 더 빠르게 아마 세팅이 되지 않을까라고 생각합니다. 예.
And David, can you share your idea what other companies in states or any other countries setting their organizations for this kind of cloud journey or adaptive technology?
A key learning is that you cannot apply wholesale change to your organization. Because there's too much resistance. And so where we see it successful is when people create an initiative around cloud and create a cloud program team, it could only be 2 or 3 people. It doesn't have to be a big group of people. And you say, okay, great, we're going to stand up this externalized infrastructure for everybody. That's step 1. And then step two is then finding a business group or a business partner that's willing to be your first user. Goldman Sachs has talked publicly about how they did this with one of their business groups with us. They picked one team, and then a year later, everybody adopted that. So step 1 is create just 2 or 3 people who are the coalition of the willing to say, yes, we will create a cloud program approach. Let us champion how to be that cloud program office. And step number 2 is finding a business partner of development teams to prove success with you. That's option number 1. Option number 2 is, you'll see this is why our products do very distinct things. If you are in the ops organization, you can just start with Terraform today. It's not that big of an ask of your organization. If you're in the security team, you can just start using Vault. If you're in the networking team, you can just start using Console, because they are independent problems. So the option 1 is if you want to take a holistic view. Option 2 is if you want to be very practical. Most people start with Terraform. And number 2, they go to Vault. That's generally how it starts, because there's a very clear owner of those things. Networking tends to be shared by more people, so that one's a harder one to start with unless you've got a single organization. So Terraform and Vault as a starter would be the recommendation.
제가 추가로 하나 더 말씀드려도 될까요?
네, 말씀해 주셨습니다.
예, 일단 뭐 알다시피 이제 그 질문 중에 보면 이제 대부분 다 기업들이 아마 사일로로 아마 운영, 보안, 개발에 따로 돼 있을 거고 특정에만 있을 건데, 저는 아마 클라우드 AWS 서비스를 쓰게 되면 아마 기본적으로 아마 이런 컨설팅을 받게 되면 기본적으로 이렇게 하기 위해서는 CCO의 조직 같은 걸 얘기할 겁니다. 얘기할 거고, 대부분 그렇게 되면 운영 담당, 그러니까 인프라 담당자, 이제 보안 담당자, 그다음에 개발 업무 담당자 하는 메인 업무를 하고 있는 멤버들이 같이 모여서 어떻게 보면 TFT처럼 아마 조직이 될 거고요. 그 조직에서 그 경험을 확산시키고 그 경험을 가진 사람이 다른 또 이제 밑에 또 어떻게 보면 소규모 또 조직을 만들어서 그 전사적으로 확대하는 방향 아마 이렇게 얘기를 할 건데, 저는 개인적으로 생각하는 건 아마 대부분 엔터프라이즈 기업들이 지금 가장 큰 그러니까 제한 요소 중에 하나가 아마 보안적인 요소일 거라고 생각합니다. 왜냐하면 IT 기업 같은 경우는 일반적으로 보안보다는 속도와 개발, 그러니까 그런 개발 속도, 운영 서비스 위주로 하다 보니 속도 빨리 가고, 엔터프라이즈 기업 같은 경우는 아마 보안이 아마 되게 중요하게 되다 보니 일단은 약간 속도보다는 이제 안전, 보안 이런 걸 위주로 하다 보니 아마 되게 느린데, 현재 추세를 보면 이런 이 속도를 안 따라가면 이제 뒤처지는 상황이 되는 거죠. 이 뒤처지는 상황을 따라가면 이제 속도 따라가야 되는데, 저해되는 거는 결국은 보안에서 걸리게 됩니다. 그래서 아마 저희 측도 얘기한 가장 큰 것처럼 인프라와 개발에서 앞서 나가지만 결국은 내부의 보안팀과의 그 멤버들과 협의와 감자, 그리고 보안을 담당하시는 보안 담당자분, 그 C-레벨 분들에 대한 의사결정, 어떻게 그러니까 전략이 기존에 있는 IDC와 기존에 있는 온프라미스에 있는 그런 전략에서 클라우드에 있는 새로운 보안 전략을 빨리 만드셔가지고 고급 약간 유연한 보안 정책을 가져가야지만 현재 있는 현재 IC 통해서 데브옵스 IAC 다 보시면 이게 영역이 나눠지지 않아요. 개발자가 콘솔에 들어갈 수밖에 없는 상황이 생기는 거고, 근데 그걸 약간 제한하기 위해서 아까 제가 알고 있는 SI에서는 SI라는 플랫폼을 만들어서 그런 이름을 만들어서 한 거고, 그렇기 때문에 결국은 보안에 대한 첫 번째는 제가 보기에는 보안에 대한 전략이나 이런 게 수정이 돼야 될 것 같고요. 그래서 그 멤버가 클라우드나 이런 이제 새로운 신기술에 대한 이해도를 높일 수 있게끔 교육이나 이런 게 먼저 우선이 돼야 될 것 같고, 당연히 인프라 뭐가 주도냐에 따라서 인프라가 주도면 인프라 위주에 될 거고, 개발이면 개발 위주에 될 건데, 엔터프라이즈 기업 같은 경우는 대부분 SI 위주다 보니까 아마 개발 위주보다는 아마 인프라 위주로 많이 준비가 될 거라 생각하고 있어요. 근데 그렇기 때문에 저희도 뭐 비슷하고, 그렇기 때문에 인프라와 보안이 많이 좀 협력을 해서 초기에 좀 많이 좀 어떻게 보면 이런 전략적으로 좀 앞서 나가야 되지 않을까, 그런 조직을 만들어야 되지 않을까. 그리고 그에 있는 스폰서십도 보면 단순하게 인프라 조직에 있는 스폰서십이 아니라 보안 조직에 있는 그런 스폰서도 같이 받아야지만 좀 더 빨리 이런 환경을 구축할 수 있을 거라 생각합니다.
네, 감사합니다. 실질적인 고객사 입장에서, 운영자 입장에서 말씀해 주셔가지고 고객분들이 많이 좋아하셨을 것 같아요. Well, then we have another question. Well, for the infrastructure modernizations, HashiCorp product portfolio is quite good, and I know Korea HashiCorp is investing in Korean markets, the resources and the partnerships, right? But do you have any specific plan to invest the consulting teams or the service teams, because Korea is quite early stage in the markets for this journey, so we need to get more educated and enabled in the cases. So do you have any plan?
Yeah, I think the short answer is there's a consulting gap everywhere in the world, not just around HashiCorp products, but about cloud in general, because there's so much demand. So the answer is yes, we do have a small consulting organization in Asia Pac, and David would be able to comment more on that. But number two, we are investing as fast as we can in the partner ecosystem locally to try and get capacity locally. So we have a partner function in Asia Pac specifically trying to do that. And I'll defer to David on how many partners are available in Korea, as well as how many consulting resources we have. That would make the broader point that there is just a skills gap in the market in general, which is why, and that is just because everybody's going to this new platform all at once. It's the same way that there was a skills gap after the mainframe era going to the data center era, and it's the same thing happening again. And it's also why we are starting to offer our products as managed services. And I think maybe that explains why, because we have a portfolio now of HCP, Vault, and Console, and I know they're not all available in the Asia Pacific regions, but that's driven by demand. So if there's demand for us to run managed services for you, we have that facility. And I would ask just your guidance on, if people are interested in that, the local team is the best place to ask.
Right. And here's another question is, well, you introduced us as like Terraform, Vault, Console, and Nomads, so we can orchestrate the whole multi-cloud infrastructures and automations. So if we distribute or run same workload to multi-cloud service providers, such as AWS and Azure, could we manage traffic routing, such as AWS 70% and Azure's 30%, so that we can manage the different routings?
So I think the core principle is unless you build your application very specifically so that it does not use any of the cloud native services, the answer is no, right? If you're building an app on Amazon, it's going to be using the Amazon Kubernetes service plus their load balancers plus their databases plus, and so that application is designed to be built on Amazon. And so you cannot move that application to Azure because those core services don't exist on Azure. And so like the core notion of multi-cloud for us is acknowledging that It's mostly not about moving applications around because they are built on a specific platform, and rather just having a common operational fabric across it. That would be my simple point. However, there are exceptions to that, and I think Zoom is the best exception to that, right? Zoom, if you read a little bit about how they share how that application is built, Zoom is actually designed to run on private data center. So that it's a massive fleet of private data centers that they run. And so it is built in a cloud agnostic way. It runs its own stack. When Zoom came under enormous load, well, it turns out they run the private data centers. They use, cloud native concepts like Terraform, Vault, and Consul, let's just say, as the way they do that. But that application is built to be self-enclosed. When they came under a massive load, because they use Terraform as the basis for how they interface infrastructure, they were able to spin up compute on Oracle Cloud, drop that application and send a portion of their traffic to Oracle Cloud. But again, it's not using any of the Oracle services, it's just using Oracle compute. And then they were able to Terraform apply more compute resources on Amazon, some Terraform apply resources on-prem, and now they're actually able to shape traffic across them. So that my core point is no, generally not, unless you specifically design your application to do that. And I would argue that for most people, it's generally not worth the effort of building an agnostic application, just because for practical reasons, you're not going to move it around unless you have an application like Zoom.
All right. On top of that, if we try to move the workload from the AWS to Azure, can we do kind of cost simulations with your orchestration tools like that?
So yes, there is a cost estimation capability inside of Terraform Cloud and Terraform Enterprise. So yes, at a broad level, but there are also companies that specialize in this that you could plug in to your Terraform template, and they'd be able to tell you roughly what it would consume. I think that the takeaway here is by standardizing the market on Terraform, it enables all these derivative use cases like, oh, what's the cost of running this Terraform template? Okay, pretty straightforward. We know what it's going to do. We don't know what the networking costs are going to be or the storage costs are going to be. We do know what the infrastructure costs will be. So the Terraform template is probably the right starting point for calculating that value.
All right, thank you. 또 질문이 있으신 분들 혹시 계신가요? 저희 하시코프 데이브 알게 또는 아모레퍼시픽의 재열님에게 질문 있으시면 지금 편하게 타이핑을 해주셔도 되고요. 저희가 질문이 더 있으신 잠깐 기다려보고 없으시면은 이제 좀 마무리를 하면 될 것 같습니다. 다양하게 저희 현재 고민하고 계시는 그 클라우드 프로젝트들이나 컨테이너 프로젝트들에 대해서 질문 주셔도 괜찮고요. 혹은 궁금한 어떤 질문도 괜찮습니다. 네, 별도로 더 추가 질문은 없는 것 같고요. 우선은 그럼 다시 저희의 박세준 성무께 마이크를 넘기겠습니다.
네, 많은 좋은 질문 해주셔서 행사를 빛내주셔서 대단히 감사합니다. 이른 아침이었는데 너무 감사한 마음을 전하기가 부족할 것 같은데요. 어쨌든 1시간 반 정도 예상했는데 한 5분에서 6분 정도 좀 오버가 되긴 했어요. 질문을 많이 해주시고 저희가 말씀을 많이 서로 나눠서요. 물론 많이 부족합니다만 이걸로 오늘 저희가 준비한 행사는 모두 마무리가 됐습니다. 오늘 공유드린 내용들이 조금이나마 업무하시는 데 도움이 되거나 혹은 참고하실 수 있는 내용이면 참 좋겠고요. 그리고 앞으로도 저희 하시코프 제품하고 기술에 많은 관심과 격려를 보내주셨으면 하는 바람입니다. 특히 제품과 기술에 관한 추가적인 질문이나 문의사항은 언제든지 저희 코리아 팀에게 연락 주시면 적극적으로 대응드리고 협의해 나가도록 하겠습니다. 끝으로 바쁘신 와중에 오늘 소중한 시간 내주셔서 참석해 주신 모든 분들에게 진심으로 감사드리고요. 그리고 오늘 발표해 주신 발표자분들에게도 감사를 드리겠습니다. 그럼 오늘 세미나는 이걸로 마치는 걸로 하겠습니다. 남은 하루도 건강하게 즐거운 시간 되시고요. 그리고 좋은 주말 보내시기 바라겠습니다. 감사합니다. Thank you all. Have a great day.